Good evening, everybody. Appreciate everybody coming. Obviously, a topic of considerable interest to everybody, particularly given the warm winter that we've had and lack of moisture. I haven't seen this many people in here for a presentation since we had that golf thing going a few years ago. I don't remember that, Bill. Do you remember that? Okay. So I've kind of set the stage here and why we're here. So kind of with apologies to one of my favorite television personalities, Johnny Carson. So bear with me here. So we're glad you decided to dive in with us. We want you to be less underwater with your water bills. We want you to think of this series as an opportunity to soak up practical water-wise information. We promise not to drown you in technical jargon, just simple, usable ideas. And we also promise with the tools we'll give you that you will turn the tide on water waste. Listen, don't blame me. I just read what they give me. All right? Okay. I'm Phil Goldstein. Usually those of you, and I see some familiar faces, will see me on most first and third Tuesdays in the month, sitting up here on Planning Commission. Joining me, my wingman over there in the middle seat is Marty Jost. He's Vice Chair of the Planning Commission. I'm very privileged. Marty and I both are privileged. I think it's safe to say we're serving on a working group that was set up by the planning staff several months ago to look at all things conservation, water conservation-wise. We've really only begun our work. Tonight's first of four sessions on the Spring Water Series is really the first effort that we're putting forward. Following the conclusion of this, the four sessions, we're begin to look in earnest at other ways that residents of Tinmouth can save water. But this is our first effort. The other members of the committee, besides Marty and me, we have privileged to have two members of council. We have Mayor Pro Tem Luke Wagner, and we have Council Member Bill Jenkins, who is here tonight, which we appreciate. And then we have two members of the planning staff. We have Principal Planner Logan Graves and Planner Lindsay Jones. I'd also be remiss in not acknowledging Lindsay's done. I don't believe Chad's a member of the committee, but if he doesn't have enough to do, we can certainly give him something to do on the committee. I'd be remiss in not acknowledging Lindsay has done most of the heavy lifting on this water series, and deserves a lot of credit for that. So anyway, and then last but not least, Ben Boddicker, communication specialist. Appreciate everything he's done getting the word out. Appreciate what you all will do if you walk away from this tonight with even a little bit of information that helps you getting the word out to your friends about the following sessions that are going to happen. So the focus of these sessions is really how can residents be more efficient with water? Talking about water waste, which is obviously water is becoming more scarcer and more expensive. Anybody that's looked at their water bill lately. Tonight's topic is Sprinkle Smarter Irrigation Tips and Technology for Your Yard. April 30th is the second session, which I imagine will be of interest to everybody that's living where there's an HOA or a metro district. That's Know Your Yard Rights and Landscaping Rules. That's essentially, as I view it, what your HOA, your metro, and even the town of Tinmouth can tell you must do, or more importantly, what you can't do, and meanwhile, what you can tell them they can't have you do. So the third session, May 14th, is Transform Your Yard, Water-Wise Landscaping. I recently had a tour where we got to see a lot of different aspects of water waste conservation landscaping. I think that one will be very interesting. And in our last session on May 28th, easy ways to save water inside the home. I'm hoping that's a little bit more than just that old adage about showering with a friend. So, before I introduce tonight's speaker, a couple housekeeping measures. Did everybody receive a numbered ticket? Good. So this is for one of two giveaway items that we have tonight. And I'm going to turn over, Marty. Could you, I appreciate if you would tell the folks here in the studio audience the nice parting gifts that some lucky contestants are going to have an opportunity to win here tonight. And those are valued at how much here on The Price is Right? Okay, we've got two of those that we will. Great, thank you. Couple other things. You should have also received or can get from Lindsay, right, some cards. Appreciate if you would hold your questions till the end after our guest speaker's presentation is over. And if you have questions, write them on the card and somebody will come and hold them up. Somebody will come around and collect them. If we have time at the end, we will perhaps take some follow-up questions from the audience, but that's how you will submit questions. And I'd ask that you please keep your questions focused on the presenter's information tonight. If you have questions about the town's policies, on what the working group that we're part of is doing later, you're certainly welcome to attend a planning commission meeting or a council meeting, and you can offer your thoughts or questions to council. But please keep your questions pertinent to our presenters' information tonight. So with that, I'd like to introduce our guest speaker tonight. This is Scott Curry. He's assistant professor of CSU College of Agricultural Sciences, and he specializes in water efficient irrigation and landscape management. And I'm told he's going to share straightforward tips on watering your landscapes more efficiently. So with that, Scott, the podium is yours.
Hey everybody, thanks for being here tonight. I really appreciate just seeing everybody be interested in this topic. Just to kind of put this in context for you, so this is actually the driest winter that we have kind of in recorded Denver water history. So if you look at some of the graphs from the USDA right now, I believe it was 1987 was actually the worst water year that we've seen in a while, and this is making that look quite a lot better. So it's really important that we're conserving water right now, and I'm going to do my best to help all of you take some steps to do that. Let's see if the PowerPoint's going to work. Break it already? Left or right? There we go. Sorry, everybody. First time in the council chamber. No, I was not thinking it was going to be in this room. But I just wanted to do a quick about me real quick. So I'm assistant professor at CSU. I teach primarily in the landscape design and contracting program. So I'm a licensed LA certified irrigation designer through the Irrigation Association, and then also a qualified water efficient landscaper. So a couple of certifications that are just associated with water management. I grew up in the landscape business. My dad was a commercial installer since about the mid 80s. So learned a lot really quickly about just landscaping and irrigation. A couple degrees as well from CSU that are all associated with landscape related stuff. So we're going to start with some science, everybody. I think it's really important that we understand some of the mechanics of how this stuff works before we get into all smart technology. Because I think one of the things is, when we talk about this technology, is why does it even matter? Some of this stuff that we're going to talk about right now is going to be those reasons of why it matters. So the very first thing that I want to talk about is evapotranspiration. So evapotranspiration, if you don't know, is basically the mechanism in which plants use water. So no matter what it is, turf grass, whether it's a yucca or a tree, it's going to have a certain evapotranspiration rate that is associated with it. So that's typically going to be in an inches per day value, and it's usually a fraction of an inch. Like if you had 1 inch of ET that's occurring in one day, that is a massive amount of water that's leaving the system. So one of the main goals is with irrigation is to recharge this sort of system that we have. I like to think of soil as a cup, and irrigation is kind of how we are filling that cup up again. So ET is kind of water out, and irrigation is sort of water in. Same thing with like rainfall would be another example of water in. So just the way that plants use water, and this is getting into some technical aspects of this, everybody. You don't need to know everything about what I have on this slide. You're probably seeing some things about pressure bars and how root hairs are pulling water out of soil and things like that. Essentially what I want you to know is there's a process of how irrigation works. Some terms for everybody. So if we've ever heard, probably nobody has ever heard the term field capacity. What field capacity means, that's when your irrigation or your soil profile is full of water. This is good. This means nothing is left just yet. Another term is kind of the bottom range, which is going to be what's known as permanent wilting point. The permanent wilting point is essentially like that plant absolutely can extract no water. It is impossible, and most of the time that plant is dead. So in between those two values, there is this area that we call management allowed depletion. So management allowed depletion is essentially the value that would indicate when you should irrigate. So understanding, like, let's say that between field capacity and permanent wilting point is 4 inches. So typically management allowed depletion is going to be like 50% of whatever your profile is. I'm not getting into all the math that's associated with rooting depths of plants and things like that because I don't want to get too crazy for everybody. But essentially at 50%, that means if 2 inches of ET occur in a certain amount of time, that's when you are triggering irrigation. So that's when we're going to say, okay, it's time to water, and we are going to fill our profile back up again. So it's just that constant process of drying and then wetting. So here's just another diagram of that too. I think it's also important to talk about saturation as well. So how soil works is there's what's called pore space. And that's typically where air exists. It's all good. I teach the college students, so that's not the first time that's happened. But yeah, essentially pore space is air. If all of you have ever heard against like the battle against compaction, essentially why compaction is so bad is because it takes pore space out of soil. We aerate in order to keep a lot of air in our soil so water can actually infiltrate. It's kind of like water in, air out with this. When the soil is truly saturated, that means that no air can enter that soil anymore. It's as full as it can be. It's actually a bad thing because you're losing water off the bottom. This is what's known as like gravitational drainage, and you are losing water. That's water that the plant can't even use. This is overwatering, essentially. If you have really bad saturation, what can happen is you can actually drown your roots. You can drown a plant because it needs air in order to sustain life. So we want to try and water to field capacity, not overwater either. That's why understanding that value is really, really important. So intake rate. This is particularly important in our climate because for the most part, we have very, very heavy clay soil. And what that means is it's really difficult to get it wet. A lot of times what will happen if we apply water too quickly, water won't actually even enter the soil profile. That's when we're getting runoff, and that's another way that we are wasting water. So for example, one of the things that we're going to get into later about different types of nozzles is your typical NPR nozzle that everybody is using in an in-ground irrigation system waters really, really quickly. Like 1.5 inches in an hour, that's like monsoon rain. Like it's that aggressive in there. So if you try to apply, like let's say a whole 2 inches of irrigation all at once, if you look at this chart, this is from the Irrigation Association, you can actually only apply 1/10 of an inch of water before you're going to start to get runoff. That means you are losing that water almost immediately. We'll talk a little bit about cycle and soak, which is a feature that you're going to see in a lot of smart controllers as well, and why that's important as well. So we're also going to talk a little bit about the landscape itself, because I think that a lot of times is almost even more important than the irrigation system. The way that we're actually composing our landscapes can be really, really important. So one thing I just want everyone to think about with this slide is hydrozoning. So the concept of hydrozoning is pretty simple. It's basically just group plants with similar water needs together. So if you have a garden, let's say a vegetable garden and a turf zone, those have different water needs, and having those on the same irrigation zone is going to lead to possibly overwatering vegetables or underwatering turf. You want to make sure that you have more zones to account for all the conditions that you have on your property. Same thing with like drip irrigation. We got to make sure that we're separating drip irrigation, like for our plants, perennials, trees, shrubs, from our turf zones. And this can be tough to do sometimes, but if you have different conditions or different plant types that are happening on your property, if you really, really want to get exact about it, some people even organize these things by aspect, like north side versus south side, because water changes by microclimate. That's another thing that you can also start to think about. But the concept of hydrozoning, super important just for getting the most precise application that you can get within your irrigation system. So just a quick look at this just to demonstrate an extreme example of a bad hydrozone. So we have a saguaro cactus that's planted directly in St. Augustine grass. A cactus, like a saguaro, 3 to 6 inches per year is all that needs. It would actually probably thrive off natural precipitation. St. Augustine grass, like in a place like Arizona, 1 to 2 inches per week. You are giving way too much water to that saguaro cactus, and you are going to, a lot of times, you will probably kill that cactus because of this. It'll get root rot and it'll die. So thinking about those things with this, we don't want to layer plants together that are going to have significantly different water requirements, or you're going to have one thing that's either under or over watered. That's the whole idea of hydrozoning. I think this one's really funny too. Some of you may be familiar with this. This is a Hesperaloe in the front, and there's also a Japanese maple in the back. I don't know if anybody's ever tried to plant a Japanese maple out here. They usually don't last long. They love to sell them in garden centers, but not a great plant. We have just an absolute mishmash here. Boxwood with this Hesperaloe, with this Japanese maple, and this is just a mess as far as hydrozoning goes. One thing I will say for all of you when it comes to selecting plant material, it's kind of ambiguous what plants need, what kind of water. A lot of times it's boiled down to 3 words: high, medium, low. What does that even mean to a lot of people? We try and group low with low, moderate with moderate, and high with high. There can be more nuance to it than that even, and that's one thing that within some of the literature about plants, it'd be awesome to get out to people just to make this process easier. So just back to hydrozoning one more time. No matter what you have, if you have a vegetable zone, a drip zone, and a turf zone, 3 different zones for those. Run those at different times. They have different precipitation rates, and those are going to be the things that give you the most precise applications. We don't want to mix a bunch of stuff together, or your landscape is definitely not going to perform as well as it could. So another big one right here. So this is just the principle of matched precipitation rate. So there's one big thing that's in bold on this that if you take away anything, at least for watering turf tonight, is do not mix your nozzles. So if you have like an NPR nozzle, which is just like your basic spray pattern, it usually sprays a full circle, or it sprays like a quarter of a circle or a half. Those are typically NPR nozzles is what those are. If you have an NP rotator, if anybody's heard of that, make sure everything within that zone that you are watering is that nozzle. You want to make sure that we are matching the amount of water that is coming out within your zone, because if you have one spot that is getting watered way, way more than all the other spots, you're going to have one spot that's probably at saturation or a wet spot within your yard, and then some things that are really, really dried out, and you're going to have not the best lawn that you could have. I have a little profile picture, I think, right here that kind of demonstrates this when you don't have matched precipitation rate. And I want to go back to that whole idea of field capacity, management allowed depletion, and permanent wilting point again. Because if you have like that top image right here, and you are applying a very even amount of water to your area directly to that depletion area, that is what an efficient application actually looks like. If we're talking about like a 50% area right here, there's going to be spots that are way overwatered and some that are underwatered, and you are just going to have an all-around not well-performing system if you do that. You have actually 2 bad things on different ends of the spectrum occurring right here. So match precipitation, everybody. Apply an even amount of water to these entire things. Even if you have multiple zones of turf, you can have multiple different nozzles actually occurring in different zones as long as everything within that irrigation zone is the same. You are going to have to adjust the time, though, to account for just those different precipitation rates. So just going back to head layout as well, and hopefully everybody has heard this before, but always head-to-head coverage in order to get that good, even application. So what that means is that spray arc of your sprinkler head should spray directly to the other arc of another head. I think people sometimes get confused and they do what's called arc to arc. So what that would mean is just like there isn't a sort of spray head where there should be. And that's going to lead to, once again, inefficient application in our spray system. So it's kind of hard to see from a profile view right here, but I think it's actually a little bit easier when we look at something like this. What I always tell people to look for is kind of this pinwheel pattern. If you look at 4 heads, like in the corner, like where the 90 degrees are, you're going to see these ellipses that are meeting to create that pinwheel. That is going to be the sign of really, really good coverage. Everything is kind of in that nice square space. Not everyone's yard, though, is going to be a perfect rectangle, and I understand that. Sometimes you have to do the best that you can in order to achieve this. One thing that you can actually also do that I don't have a diagram is triangular space head to head, but do your best to try and achieve that head to head coverage to get the most efficient application that you can. If you're getting this nice even application, you're going to be able to have greener grass with less water. So now that we're through the actual science aspect of this stuff, we're going a little quicker than I thought we were going to. So hopefully we have some questions at the end too. Again, submit those on paper, everybody, and I'll stick around and we'll try and answer as many questions as we can about this stuff because I know there's a lot of technical jargon that gets associated with this. But here's the one thing that if I could tell every single person in this room they could do one thing in order to improve their irrigation efficiency today, I would tell you, get an irrigation audit. What an irrigation audit is really going to do for you is it's going to tell you if you have a matched precipitation rate. It's going to make sure that all your spray heads are level, operating property, that you have head-to-head coverage, that you don't have any damage to your system. There's a lot of different things that we can see from going out and actually running an audit on our system. So one thing that I put out in the handout today, and we're just going to go over this to do a home audit, and then we'll talk about some of the benefits of doing a professional audit as well. So for the at-home audit, essentially what we're going to do, you got to use containers that are all the same. If you use something like these little wine glasses that they're showing right here, little shorties, that's a perfect thing to be able to use for this. You just have to make sure that your containers are all the same. So the number that I'm going to have everybody put within their irrigation zone is 12. So you're going to try and get those, like in the extension literature, it's going to say to put those kind of randomly throughout your lawn. I would encourage you to have some rhyme or reason to that just based on the shape of your irrigation zone. So you get those out there placed and then you are going to run your irrigation zone for a typical cycle. So whatever you might think that is, it's going to typically be, hopefully for a spray head, 8 minutes, 10 minutes, like at max for something like this. Run that for that 10 minutes to see where it is, and then we are going to take a look at it. One thing to note during this is a great time to actually see if you have damage to your system. I think the biggest culprit actually for people for irrigation efficiency is not level heads. It's really easy, especially if you have stuff that's directly adjacent to a driveway or a patio or something like that, for it to get tilted. So if you get in there with a rock bar or some sort of tool that you have in order to get those things level, take a torpedo level, put that on top of that head and try and see that that's level in those two directions, and that's going to tell you that that head is now going to spray as evenly as it can. Same thing if you're noticing things like chips, breaks, other damage to your nozzles. Go through and look for those small things. Blockage. Any kind of small thing, it's amazing how just like something like a grain of sand within these tiny orifices of these nozzles can cause like bad application right here. I would encourage some of you pull all your nozzles off and even flush your system if you are not dealing with clean water. Like if you're in a reclaimed or dirty water situation, well, whatever it is, flushing your irrigation system is going to be part of yearly maintenance to keep that thing working properly. So keep all those things in mind. This is just a great time to look closely at what's actually happening. One thing that's tough about irrigation happens in the middle of the night a lot of times, and it's okay to test this and get this right just while you are paying attention to it. It's a great Sunday afternoon project, I think. So after you have your irrigation zone kind of run, and you should be catching water within your cups, what you're going to do now is you're going to measure it. So the thing I want you to look for as you are measuring this stuff, you're looking for things that are either way more filled than other cups or way underfilled from other cups. What that is going to tell you is that you have an under-overwatering issue. So at least you know where to look within your system now. You should say, what is happening right here that I'm getting way more water in this corner? Or why am I not getting as much water right in this area? Typically, it's going to be those things I already talked about. It's going to be leveling your heads. It's going to be head-to-head coverage that's out there that's causing these issues. Sometimes it's just easy to see this physical representation that this isn't as efficient as you think. I actually have one quick question for everybody. Who has an in-ground irrigation system here? Just a raise of hands. Good chunk of you. Is anybody using hand water or like hose sprinkler in here? Cool. We're going to talk about that as well, how we can do some things even to improve that as well in the technology section. Because this is definitely a little bit more geared to in-ground irrigation system. I would encourage people, if you can, if it's within your means to have an irrigation system, I would encourage it, but it's not 100% necessary. But just something to think about. It's a great home upgrade, especially if it's done properly. So professional auditing. You will pay, I think I saw recently somewhere in the neighborhood of about $150 to $300 to get a professional audit done. But what this is a professional will come out to your house. They will do a 24 catch can test on your largest zone, and they will give you this value that's called distribution uniformity low quarter, or DULQ, and that's going to be shown in a percentage value. And what that does is tell you how much water is actually going into your system. This is actually a very integral percentage to have when evaluating how much water the plants actually need, because effectively what makes up plant water use is going to be what's called reference ET times a crop coefficient, and then times our efficiency, and that tells you the real plant water requirement. So if you have a 50% efficient irrigation system, in theory, you actually have doubled the plant water requirement in order to get a good application on this. This is why irrigation efficiency is so important. If you have a system that is auditing more like 70 and it's a spray system, congratulations, you have a really well-maintained system that is saving you some water. I will say, once we're starting to get into 70, 75, 80, you're talking about lab level conditions. When people say that you can get 80% efficiency from certain nozzles, that's like in a vacuum sealed warehouse, like that has no wind. Like, we have to account for some real world conditions with this. The world's not perfectly flat, and there is always a breath of wind, it seems like, in northern Colorado. So we have to take this with a grain of salt. One thing I would say, though, if you get this done with an in-ground irrigation system and you are seeing a number that is 50 or below, there's something wrong. And it's definitely time to really take a hard look at what's going on with that system. With these professional audits, they're going to give you a list. They're going to tell you, we got heads crooked, the pressure's bad, blah, 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 blah. I didn't get into system pressure, but it's actually something like if you know that you have variable water pressure, high or low water pressure, that can actually be something that really throws off efficiency as well if certain things are not done properly. So keep that in mind. It's good to have, like, if you have 70 PSI coming out of your hose tab, that's good. You're going to probably not have any issues. If you have something like 35 coming out of your hose tab, that's going to possibly cause some issues, even with doing the right thing. Really high pressure can actually do the same thing as well. Like if you have like 100, for example, it might be time to actually reduce that pressure because that's going to also hurt irrigation performance. These professional audits identify some of these things that you can't actually see. That's one of the hardest things about irrigation is some of this stuff is almost invisible. It's in the ground. It's kind of mystical. It's not super, super crazy, like if we even look at it on surface sometimes. But definitely getting in there and putting this performance metric in here, I think helps people understand like what's going on a little better. So now we're going to start talking about some of the actual technology pieces that we can implement hopefully today that are going to help you get a little bit more precision application, make your life easier, whatever it may be. So I will say this, even if you have the best technology implemented on your property, it's not a silver bullet. It's not immediately going to make you efficient. You're still going to have to manage this system and put some effort in and to make sure that it's functioning properly and that we are scheduling our irrigation properly as well. It can help you make good decisions, but sometimes just setting and forgetting these things and expecting it to do all the work, we can't do that. It's the same thing with like the AI revolution right now. That'll never happen. Like it can do wacky things that are unintended and make your water bill go sky high. So always be paying attention to these things no matter what. You are not immediately efficient just for having good technology implemented. So first off, we're going to talk about smart controllers. Does anybody know that they have a smart controller in their home? Cool. So the awesome thing is with smart controllers, if anybody is running their irrigation from an app, essentially, you probably have a smart controller. If you have a traditional dial style timer or clock, some people call it, that's probably the lowest level of irrigation scheduling because it's kind of hard to manage just the changing of the environment with this. How these smart controllers work right now is what they do is they're tapped into the National Weather Service or some other water provider, and essentially what those do is they tell you how much ET left the system. So if I know, like over the 3 days between my watering cycles that we lost, let's say 0.6 inches, and I have a sprinkler head that puts down 0.6, that means in the next watering cycle, I need to water for an hour. It just knows that because it knows how much water has left our system. So there are microclimates that have different water that comes out of them. If you have some parts of your property that are really shady versus really sunny, it's going to be variable. That's the one thing about these ET controllers that needs a little bit of tweaking from us or some on-site knowledge to do it. But it's not just a dumb 12 minutes every time, every month, if we are actually using the data that's available to us. And that's why these smart controllers can have some value to us. The other thing is these also have rain and freeze stops in them without actually having a sensor on your property, which can be a big value as well. I'll send you an app and it says we're going to delay because there's going to be a freeze tonight and we don't want all your heads to get damaged when there's water coming out of them in the middle of the night. Great, that's good. It's going to delay until soil comes up. Same thing with observable rainfall. If we know that we're going to get a 1-inch rainstorm that's coming through, it's probably going to not have irrigation scheduled for a while because your profile is full or at saturation. That's why I would say if you were going to implement one piece of technology today, go to Home Depot and buy a Hunter Pro C. So it's about $250. And that is going to be one of the things that can make a pretty big difference. The other one that I actually really like that's super easy to use and isn't horribly expensive is the Rachio 3. So that Rachio 3, like some homes come brand new with those. Those are probably right around that $200 range as well. App controlled, works based off ET. Has a lot of these smart sensors that are integratable with those things. One thing for this presentation, I just wanted to make sure a lot of the things that I'm talking to you about today are attainable. Like you could go get this tonight if you really, really wanted. If you know you have that traditional style controller, I would tell you that this is a great year to invest that $200. You might even be able to find a tax rebate that's associated with doing this. I'm not sure if Fort Collins, Loveland Water, they might actually have a rebate for you as well in order to implement some of these things. Make sure to look into that stuff because you could get something like this for free, and I promise you, it will make your life easier. I love that I can control my irrigation from an app too because I have squatted next to too many irrigation controllers in my day. It's not a fun thing to have to twist the dial and punch the button and actually figure stuff out, or I forgot to do the seasonal adjuster, yada, yada. Much easier to just do it from anywhere. Even if you forget about it, I can say, I'm turning that off right now, or something bad is happening. This is a great tool. So going back into the apps. So Rachio has their own proprietary app. I find it super, super user-friendly. It walks you through the setup, how it works, and it actually can give you recommendations immediately just based on the weather that's occurring in your area. So that will help you set your watering numbers like immediately. You don't even have to give it any initial input. It should say, based on the weather that you have been having recently, we should probably be watering, 15 minutes if you're going to water 3 times a week, which I would recommend for everybody when it really becomes watering season. Try and keep it like probably to no more than 3 times a week. It means that we're going to have to water deeper and slower in order to do this on those 3 days. But it's not going to get as much frequency. The more frequency that you have, that also kind of opens up the door to water waste, and you actually could make your lawn more resilient by letting it drive roots. We'll talk a little bit more about root driving maybe at the end of this as well. Other things that you could do. This is something that's more beyond that smart controller. So this is a flow sensor and master valve. So if you have a larger scale property, this is something that I would really start to look into, because this is something that's going to be your best leak detection source, and it's also going to help you be able to shut off your system if something critically bad goes on. So the main feature of having a really strong flow sensor is it's going to have this feature called learn flow. So what that means is each zone that you activate, it's going to know that you have X gallons a minute that's coming out of it. Let's say like 9 for one zone, 8 for another one, 12 for another one, however you have this set up. It's going to document that. And the really, really neat thing is, if you have an overflow or an underflow on that zone going forward and it knows what it's supposed to be, if you, let's say that like you have a neighbor kid who's being mischievous and they kicked off one of your sprinkler heads in the middle of the night and you now have an overflow that's occurring, it's going to be able to send you a notification to your app and say, there's something wrong at this zone. You have an overflow that's occurring. If you have an overflow, that means that you probably have damage or a leak that's occurring within it. If you have an underflow that's occurring, what that would typically mean is you have a blockage or a nozzle that's not putting out water properly in a way, and that could tell you exactly where you need to maintain instead of having to go through the process of looking at everything. This can be a pretty valuable tool pretty easily. If you had a mainline break, if any of you actually have mainline on your property, if there's a mainline break, that flow sensor also knows that there is water coming out when it shouldn't. And the point of the master valve is it can shut your system down. So if it knows that water is just free flowing, it will probably send you a big scary notification that says there's something critically wrong with your system, and it will shut it down until you disarm that. That's going to help you save water as well, and it's also can prevent a lot of damage to a property as well. If you have water that's even flowing for like a couple of hours out of even a standard tap, like a 3/4 inch tap, that's hundreds of gallons of water. And that's foundation damage. It's all kinds of different things, not to mention the water waste. So this is a way that you can also protect that as well. So this is a good implementation. I don't think every single person needs this in all situations, but it can be really valuable. I didn't put flow meters on here as well, but there are difference. So flow sensors, that kind of gives you all the learn flow and some of those smart capabilities that I talked about within your controller. But a flow meter can actually be really nice after your backflow, because that's going to help you isolate your outdoor use from your indoor use. Sometimes it's hard to know where that waste is occurring. So if you add this flow meter or sub meter to your irrigation system and you reset that to 0, you're going to be able to see on a month-to-month basis how much water that I'm actually using. You can compare it to your water bill. You could see some discrepancies actually in how that's being metered maybe. At least I now have an idea of how much water is actually being consumed by my outdoor use. I recommend it. There are some municipalities that have gone as far as having like 2 taps, one that's very specifically for irrigation outdoors and one as in or for indoor uses. So a flow meter can be a great addition just so I can isolate my sort of winter consumption use versus my watering season use. I think those are both digital and analog available. I would honestly recommend an analog one because if there's a leak within your irrigation system, you can actually see it if that needle is moving. So something to think about. So another important thing right here, and I would encourage, this is another really low-hanging fruit thing for everyone to do. So pressure regulated spray bodies. So if you don't know, this is actually required for all pop-up sprinkler sales in Colorado now. It has to be a pressure regulated spray body. There's no such thing as non-pressure regulated, or it's considered illegal contraband at this point. So why this is important is each nozzle has a certain peak operating range that it is meant to work at. So typically for like your standard NPR head, that's 30 PSI. So if you see PRS on the top of a sprinkler head, right here, we'll pass them around. So you will see on the top of these sprinkler heads, it will say PRS 30 on this. That would indicate that you have a 30 PSI regulated head. If everybody wants to take a look at that. But one nice thing about that is if you have pressure regulated heads now on your property, that's going to ensure that you at least have peak performance with whatever nozzle that you are using, assuming that it is matched to the proper nozzle. So a standard NPR, 30 PSI. Some of the more niche stream rotary nozzles that I'm going to talk about, those have higher pressure requirements. So you definitely have to pay attention to that. It's not just as easy as buying a nozzle from Home Depot and just putting it on what you have existing. You need to make sure that you are matching your pressure regulation to the nozzle type that you are using. So whether you pick a Rainbird R-Van or an MP rotator, you just want to make sure that you're doing this. One thing I would recommend, don't dig up your actual head body if you can. One of the you just have to match heights. If you have a pressure regulated guts to this, just take the lid off, pull the guts out of this thing with the lid, place your nozzle on this, and drop that into the body if you're going to replace this. That's how you can get the pressure regulated body in a shell with the proper nozzle on it without actually any digging on your property. That's going to be the fastest way, assuming that it fits. Not every time. If you have some old stuff or some kind of, if you have a really, really old system, you might not be able to do that, but it's worth a try because nobody likes to lean on a shovel. Me included. Done that too much. But pressure regulation, another low-hanging fruit piece that I would recommend for everybody. Like with smart controllers, this is the next thing that I would probably recommend in the just the order in which that this can be done for water efficiency. Rotary nozzles. So rotary nozzles are kind of the more efficient option in lieu of your NPR sprays. The reason that these are better actually has a lot to do with the size of the droplet. So these are stream rotaries more technically, and essentially why these are better is they spray at variable lengths, and the droplet's actually larger, so it's harder to move by wind. Therefore, it goes exactly where you want it to go. So some other things to think about with these. These have slower precipitation rate. So going back to that idea of intake rate with soil, you don't need to run as many cycles with these because they water slower. You have to run them longer, but just because you are running longer does not mean that you are putting down more water. It has everything to do with the speed of it. For these MP rotators, the precipitation rate on that is like 0.4 inches per hour. A Rainbird R-Van is like 0.6 inches per hour. Your standard NPR, 1.5 inches per hour. So you have the difference between an effective light rain and monsoon styles of rain that are causing runoff. If you are using standard NPRs, you need to have a bunch of cycles going if you are losing a lot of ET. You're going to have to water for 5 minutes, cycle for 30 minutes, water again for 5 minutes, cycle again. Your sprinklers won't just pop up once, they will pop up 5 times. That's how they should be if you are cycle and soaking properly. With these, you are limiting that cycle and soak. You can run them longer before you will need to cycle. With our clay soil, and if it's July, you're probably going to have a couple cycles, and that's just the reality of where we live. Something to think about with this, these can get pretty efficient. So Hunter claims that you can get up to 80% efficiency with an MP rotator, but once again, that's in the vacuum sealed lab at an undisclosed location. But if you were getting 72, 75, something like that, that's a really, really strong irrigation audit that you have right there. Like most people would say, this is an amazingly maintained system if you're getting in the 70s with this. So these are a good option. If you're really techie, I would really recommend these. Make sure you pay attention to the pressure regulation, especially on the Rainbird, because that's something that you're definitely going to have to go to a specialty store to get. Go to DBC. They will have those available, the P45s instead of the P30. Same thing with the Hunter stuff. Another thing that I would recommend for everybody, try and match your brands if you can. So like Hunter spray body, 30 PSI, Hunter NPR nozzle. Rainbird, 45 PSI spray body with an R-band. That just kind of takes some of the crazy stuff out of it. When you have like 15 different brands of stuff that are occurring all within 1 yard, it's really hard to see like what's happening, and it's hard to manage. If you know exactly what the components are, if something breaks, easy to replace. I know it's this nozzle and this spray body in order to make it work properly. This is something that we don't talk about as much, but I would say that this is actually a really great thing for everybody to implement instead of these rotaries. And what this is Toro Precision nozzles. So Toro Precision nozzles, this kind of is a nice midpoint for precision nozzles. And the nice thing is about these is they water a little bit slower. So instead of 1.5 precipitation rate, or even that slow, really 1.4, 1.6, these are right at 1 inch per hour, which is kind of a good happy medium, and it actually makes doing the math on your scheduling a little bit easier. These are great. They're really, really underused though, and they might need to be special ordered. This is not something that you can pick up at Home Depot. You'll need to go to a CPS. You'll need to go to a DBC or something that's a little bit more niche to do this. Wonderful thing about it though is it is 30 PSI pressure regulated, so it is a direct swap for whatever that you have out there right now, and it's guaranteed probably to be more efficient than what you have. So actually, this is a really interesting story how they developed it. It's actually based off Mercedes-Benz windshield wiper fluid dispensers. Weird thing that inspired this, but it actually makes a really nice, even application. So Toro Precision, even if you have really weird shaped lawns, they have a bunch of different angles that are associated with this too, which is a nice feature to have. It's not just like I have to water it with halves or quarters or fulls. Like they have things like 32.5 degree nozzles and stuff like that if you really want to get super precise shapes out of it. So Toro Precision, everybody, something to write down, something to consider. I think they're really great. Okay. We're going to talk about people who are hand watering a little bit right now, because I think this is kind of important for people to know. We're kind of through a lot of the technology with regards to like in-ground irrigation systems. One thing I didn't want to do, there are so many bells and whistles, everybody. Try and stick to just some of the basic things, getting those done first, instead of going for really, really crazy stuff right off the bat. It's really easy to get confused, and it can be really, really overwhelming with all the things that are out there. Again, smart controller, pressure regulation, updated nozzles, and those are going to help you. And make sure that distribution uniformity, it's actually putting out water how it's supposed to. You do those things, you will save water, I promise. So we're going to talk about the bucket test. So if you are watering off of a hose, one thing that I don't think people really realize, how much water is coming out of my hose every minute? Something you should probably consider if you are hand watering. So what this bucket test is intended to do is exactly that. You take a 5-gallon bucket and you are going to see how fast it take or how long it takes to fill that 5-gallon bucket. And that is essentially going to give you a flow rate. How many gallons per minute is actually coming out of this? So in my little example that I have right here, if it takes 30 seconds to fill a 5-gallon bucket, you're going to times that by 2 to get to a whole minute, and you have 10 gallons a minute coming out of this. A little bit of math involved in that, but that's going to tell you a little bit of how long you should actually be running some of those sprinklers. I think it's really easy with hand watering. You put out that, the tractor style sprinkler or the little wave style thing right there, and they just run and run and run and run. People are just trying to get their grass green, when in fact, if you have putting a ton of water on this, a lot of it's just going to run off anyway. If we're watering too fast, that's going to be kind of an issue. So understanding how much water is coming out of your tap and also understanding how much pressure it's coming out with are things just to consider with your sort of hand watering. Check that pressure. If you have really, really low pressure, but this goes for everybody. If you have really, really low pressure, you actually have like a system situation that you need to address. I hate to have to tell people like to install like a booster pump. We really don't want to do that residentially. That's kind of an expensive capital thing, and it's just to boost irrigation performance. I would think in this neck of the woods, we're not going to run into a lot of scenarios where you're getting pressures that are that low. But ideal pressures, 50 to 70, that's great for residential irrigation system. Over 90, that's when you're going to want to start to look at pressure reduction valves, because if you're hitting your heads with too much pressure, you might be starting to atomize your water, and it's going to float away, if you will. So the faster that it goes through a tiny orifice, it can get really, really thin. And then if there's that, the lovely northern Colorado breath of wind, that water's not going to go where it's supposed to. And that just leads to inefficiencies. So keep some of that stuff in mind. You can buy one of these pressure gauges that go directly on your hose for $10. Just to understand what that is. I think it's just a good thing to understand about your in-home water system. Hose timers. So all you folks anyone in here who is hand watering, don't worry, you get some technology too. So what this hose timer can do is this actually ties directly onto your tap, and this can be controlled by Bluetooth with an app as well. And what this is going to allow you to do is set an actual watering time. Instead of starting your sprinkler and then going and doing laundry or taking a nap or whatever, and it goes as long as it's supposed to go, you actually can say, I'm just going to water for 30 minutes. If I know how many gallons I'm actually putting down now too, I'm putting down this many gallons a minute for 20 minutes. That's at least going to help me regulate my total use instead of just leaving that thing out there to run and run and run. So the products that I have up here, this is a Hunter BT, and then this is I can't remember what the Rainbird is, but if you type in Rainbird hose timer, that's going to tell you what this is. I like that Hunter BT because it is Bluetooth controlled, and you can adjust it, turn it off, and it will shut that sprinkler off. It's basically just another little automated valve. It's going to allow you to turn things on, off, or otherwise. We're going to talk about something this is kind of bold new era stuff, and it's kind of unproven. Has anybody in here been to the Home and Garden Show down in Denver? Pro Green, maybe? No. So this is a system that's called Irrigreen. So what Irrigreen is it's essentially a single head irrigation system. This thing is super crazy, and what it can do is it can water basically any shape with one head within a certain radius. So it basically automatically adjusts to your shape. I would recommend, if just for fun, even if you already have an irrigation system, just look at this thing, just because I think it's really, really cool to watch it water all these really smooth angles and things like that. At the right scale, I think these can be really, really cool. It's really new technology though, and I think some of it might be a little bit unproven. I will qualify that with this. Like the claim that they make, use 50% less water. I would say, like, from a plant physiology perspective, that might not be possible. But it looks like it's very efficient just based on what I've seen. There's a lot of research. It's very new. So check out Irrigreen. If you don't have an irrigation system and you want an all-in-one package with a controller and you want to minimize pipe and heads and just all the parts and pieces, this is something that you can give a shot to. If you talk to somebody with Irrigreen, I think that they have reps that will help you come set this up as well within their app and measure the shapes and do all those things. It could be something that's pretty valuable for everybody, and so give it a shot. So other things to think about are drip conversions. This is going to be a little bit more important for what I talk about at the very end of this presentation. So drip irrigation can be up to like 90% efficient if it's done properly on the micro side. It does not work for turf just because it requires too much infrastructure. There is what's known as subsurface or inline drip, but it's very cost prohibitive. In order to do that, it's just a lot of pipe, a lot of equipment, and it's hard to mismanage because now, it's hard to manage irrigation because it's happening in the middle of the night. Now imagine that you can't see any of the water that's actually coming out because we're only watering the roots. So I don't recommend it for turf because there's winterization problems and things like that are associated with this too. I would describe this like inline drip as like the Ferrari of irrigation. With that, expensive, very high maintenance, but very high performance. Keep that in mind. They like to use this in Texas and California, but they don't have the winterization issues that we have. But drip conversions just outside of point source drip, if you're thinking about converting possibly to a more water-wise option, it's really not that difficult to convert to a spray zone to a drip zone. The only things within the actual valve that need to be changed is this one component right here. And this is a pressure regulating filter. If we add that pressure regulating filter, what that's going to help is basically your pressure get reduced and it's going to help your emitters stay put. If you put too much pressure into a drip line, those emitters that are barbed directly into the black poly pipe that some of us have seen, they'll fly. And that's going to create a leak. That's going to waste water. So we got to make sure that we're regulating at the valve before we do that. It's not super hard. It's something you have to do a little bit of digging. I've already said I loathe digging, but that's just how it is. In order to put this on, but it is a necessary component and it's also going to keep your equipment safe. Water does have a little bit of grit to it, even if we can't see it, and all those little tiny components will get worn down if you do not filter your water. If you do have a dirty water scenario, we need to upgrade the filtration and some other things. Just some stuff to think about with this. We need better options. But yeah, drip conversion, primarily for those of you, like if anybody is thinking about xeric conversions, it just starts right there. You can basically abandon your heads in place, and I would recommend that you just run black poly right on soil surface and then put mulch over it. Some people like to say that you should bury drip 6 inches deep. I disagree with that. I think it's a lot easier to just run it and pin it directly on surface and then mulch over it so you don't see it. Just some things to think about if you are kind of in that train of thought. So I think it's important that I tell you where you can actually get some of these things. So Home Depot is not going to have everything. They have very limited options. I know it's convenient for actually getting some of the real like pipe fittings, glue, things like that. Just basic stuff, but some of the more niche components that we're talking about today, especially like a better selection of controllers, a better selection of nozzles and spray bodies and things like that, it doesn't end there. Go to one of these specialty stores. If you just keep driving down the road here on Harmony, eventually you'll hit Site 1, and they have a lot of this stuff. CPS, so this is going to be in Fort Collins, like at Timberline and Vine, roughly. So not super far away to get to the CPS up there. Denver Brass and Copper, we already mentioned. They have tons of great stuff as well. Local company. If anybody wants to buy local, that's like the last one that hasn't been bought by private equity. Let's see. Home Depot for the basics. If you just need something basic, it's fine to go in there. Or buy it online. So Drip Depot, Big Irrigation, Sprinkler Supply Store, those are reputable places to also order some of these things. To be honest, I like to buy things in store, and especially for all of you who don't have as much experience with these components, it's nice to have somebody to talk to. It's amazing what you can learn just from the people in the actual store. So I'd recommend all of you go look at this stuff in store, and somebody will actually do their best to help you. The people who work in these specialty stores are more trained than your average person. They should be able to help you find what you need for your situation. So try to avoid online unless you know exactly what you're looking for. Cool. So I'm going to leave, this kind of will lead into some other themes that everybody also has, and they're going to talk about this more throughout this series. So I also want to talk about a new term, which is Coloradoscape. So Coloradoscape is actually going to be the term that's replacing Xeriscape. So one thing from a marketing perspective, everybody, and I'm sure everybody cares about the place that they live, the term Xeriscape, that has definitely not been the term, and that's actually something that I feel like has a negative connotation for your neighborhood. That would mean that somebody can basically just back up a dump truck full of rock and put it in their front yard, and that's a Xeriscape. That's bad for everybody. That's environmentally bad. It makes your neighborhood, sorry, Albuquerque. I hope no one's from New Mexico. It makes it look like Albuquerque. Sorry, got to get my bash in. But it raises urban heat island effect. There are some things that are just bad about that. It also is probably going to lower your home value as well. So we want to do this right. So Coloradoscape is going to be that new term that Denver Water is replacing with Xeriscape. The reason we don't do Xeriscape anymore is it's too easy to confuse with Xeriscape. So everybody, the new term for a turfless sort of installation is going to be Coloradoscape. I feel like that gives us some pride for the place that we live, the unique area that we live in, and some of the unique conditions. So if you can do one thing for me tonight, if you are thinking about that, call it a Coloradoscape. You'll get a lot of props from a lot of the water folks. I was actually just noticing a lot of the stuff around the county building here, or the city building here. It is a very nice Coloradoscape. Lots of great plant selections, things like that. So consider this, because even outside just efficient irrigation, one of the best things that you can do is change your plant composition. By changing to plants that use less water and then combining that with an efficient irrigation system, that's going to give you the most bang for your buck. I've actually done a study, if you want to know about how much it saves. If you have 1,000 square foot yard that's turf, you're watering it, on average, you're probably going to spend about 38,000 gallons of water watering that in a normal season. If you convert to drip irrigation and a Coloradoscape that is using really xeric plants, that's going to go down to like 8,000 gallons. So you're going to save 30,000 gallons of water a year. So that's really good for the environment. Just something to consider if you want to know the actual metrics behind that. I'd love to talk more about that, because the one big thing is, because turf is everywhere, having a nice garden in front actually raises your property value quite a bit. And there's actually research to support that stuff. So thank you, everybody. I really appreciate your time listening to this tonight. We're going to stick around for questions. If you have any sort of nuanced things that you want to ask, we will open it up. We'd love to talk about some of these things, but thanks, everybody. Sure.
How often should you clean out your drip filters?
So how often you should clean out your drip filters? I would recommend it absolute minimum once a year. If you know you're in a dirty water situation, I would recommend doing it more. Like, that's going to be the key driver, is just how much gunk you think is getting in there. But flush your filter at minimum when you turn on, and when you turn on your system, and when you winterize your system, check them both times, just to make sure that that's good for the season. If you're in more of a dirty water scenario, 2 to 3 should be plenty. Like, if you have to flush it 3 times a season, there's some goo in your water. And sometimes, if we're running out of a lake or on pump or well or something like that, it's very, very possible. So just know your water source. It definitely matters.
Which leads into this question, non-potable irrigation, should you have a filter coming into your system? I know this one, yes.
That is true. Yes, the non-pot. Yes, non-pot. You should have some filtration coming to that stuff. If you are filter, you just want to protect the components. I would also recommend going to anything that has an R that's stamped on it, or purple is what that is. And a lot of times those are equipped with other sort of filtration, filter sentries. It's just going to be more long lasting. If you're going to replace things, I would really recommend for that R, or reclaimed, or NP sometimes is the other designation that you'll see on those things. And that's going to just give you the right equipment for the job that's going to have a lot more longevity, because non-potable water can definitely do damage to standards equipment pretty quickly.
On non-potable systems, how do you measure the pressure easily? I know with mine, when I put my system in, I put a spigot by the garden so I could water it manually, and it provides an easy way to measure pressure there.
Yeah, it's going to depend on unique scenarios as well. It's like, is the pump on your site, or are you on pump that's on your whole neighborhood? Like, it'd be good to understand like what's actually the outlet pressure at the pump, and just talking to whoever your managing body is something that I would look at. Well, they might be helpful. Hard to say. Maybe it's wishful thinking, everybody. But yeah, sometimes you could actually run a stub on your input too that has a ball valve on the end of it with kind of a hose spigot, or you could do a yard hydrant, and you can actually open that yard hydrant and put that on there as well, and that will also tell you what your incoming pressure is as well. You just have to have a point in which you can connect that gauge, which... So if you have a flow sensor and a master valve, that's what another value of that would be, because it would be like no output. It'll basically tell you that something didn't come out of it, because that's another value. It would say every zone underflowed, and you'd be like, okay, if every zone underflowed, there's no water coming into my system. So that would be a value if, whoever is providing your water is a pain in the ass.
How often should a homeowner conduct a DIY catch can test?
So it's as much as you feel comfortable. I would definitely do one this year. Like, if you have never done one of these, it's a great time to do it. But I would say, depending on just noticing things when you're turning on, if you notice one tilted head on your property, there's probably another one. I would say like bi-yearly would be good. If you think you're a little bit more prone to damage, or there's a lot of wear or recreation that occurs on your property as well, where things are going to get tilted, a lot of mowing activity, it'd be good to do it at turn on. I don't think you need to do it as a professional audit every single time, but just knowing how to set up your own catch cans and make sure that things are working properly, I think is good. But every couple of years would be my answer for that, unless you think you need more. As the sort of head of your household, or whatever that is, you know your property the best, and I'll let you make those decisions.
What type of grass seed do you recommend? Not bluegrass.
What type of so one alternative just for grass seed is I would recommend turf type tall fescue. So that's going to have a little bit lower water requirement on this stuff. So as bluegrass is starting to be pretty beat this time of year, if we're going to start to do some overseeding and things like that, if we come back with that turf type tall fescue, instead of a ET rate that's like at 80% of reference, you're going to look at something that's more like 70. It's not that big of a change, but it is technically lower water use. It also depends on your situation. If you do, once again, a lot of recreation, a lot of wear tolerance on your property, bluegrass is really good at that. It's very, very wear tolerant in that way. It has a lot of things about it that make it really good. If you don't have a lot of things that are happening on your lawn, it's just kind of a lawn, those fescues can be a lot better. They just don't take a lot of traffic super well. So it very much depends on your situation. And I would encourage everybody, talk to somebody at the sod farm. What's the name of your guy at the sod farm?
Zach at NoCo Sod Farm.
talking to people in stores and reps that are experts at some of these things are going to help you make good decisions, everybody. I would encourage you to take in as much information as you can. It's not about just having to solve the world's problems by yourself. Get help from an expert. That's what I'd say.
How many years do you need to run drip lines before plants and bushes get established? And then how much water should be applied in the first years, and then how much after they're established?
Very, very dependent on the plant material. So like, for example, it also would depend on your aspect. There's a lot of things to consider within that question. If you know that you have a xeric installation and you have things like yuccas, sand cherries, certain grasses, things that you absolutely know have that, I would say 3 years. You can start to really cut back that irrigation, and those are going to really be starting to be very established and very tolerant of just our climate. For example, I have a south-facing shade garden. If you have that, I'm sorry, it's incredibly difficult to plant for. Just like the plant choices that you have are hard. There's not good xeric options for shade, everybody. If you have dry shade, there's only certain things that are going to work in that scenario. And it's something that I'm even still trying to figure out what does really well in. But you really have to look at what you actually have and what plants that you've actually selected in order to make good decisions, because that dry shade garden that I have, it's got things like hydrangeas and coral bells. It's almost like a little woodland garden. It's probably going to need irrigation. It might need irrigation forever. It's cut back, but that's just the reality of my situation. You definitely have to understand what's going on and really look at it to make a good decision there.
When do you aerate in Colorado? Spring, fall, both?
I think once a year is probably okay on this, and I think you can do either spring or fall, and I want to say preferably in the fall, because you're going to be able to capitalize better on natural precipitation during the winter, unless you had the winter that we just had.
How do you ensure matched precipitation rates on sloped front yard?
So with slopes are hard to irrigate. They really are. So one thing, it's actually kind of a design question. So in order to get the best application on slopes, what you would want to do is actually run your lines for your actual underground irrigation, parallel to the slope. So as it's descending down in lines, like if here's our slope, you would want a line that's running this way, and this way. You don't want to run lengthwise on the slope, because if you run lengthwise on the slope, that's going to make this your application get off, because there's going to be a certain degree of spray that runs into the slope of the hill. It depends on how sloped you are too. Like if you're kind of getting over 12% slope, it's not that ideal for spray overhead irrigation. But the best thing that you could do with that is run parallel to the slope.
Any thoughts on the use of moisture manager products, hygroscopic humectants, pros and cons? Did you submit a question for yourself? Using these terms?
That one's not me, and I don't know the answer to that question. I assume that might be, is that a wetting agent? So some of the wetting agents that are available this year, I would say definitely pull out all the stops, and there's definitely some value about that. Definitely read the label for this stuff, and I wouldn't over apply a wetting agent of any manner, whether that be granular or revive or things like that. But just helping with some soil moisture retention and slowing down that ET rate of your plants any way that you can without damaging the plant, I think is on the table. But just do some research about whatever that product is. I'm not ultra familiar with it. People have heard of Revive. That's the one that was at least the as seen on TV, but there are even more effective wetting agents out there that you could purchase at something that's a little bit more heavy agronomic store. So definitely an option.
How's it possible to do head-to-head watering on a 4-foot tree lawn in Tinmouth? And they give the example of 40-foot long, 4-foot wide with 8 sprinkler heads.
So I don't know if this is going to be ultra popular, but I would say a 4-foot wide turf strip is not an excellent use of turf personally. I'm sorry, guys. I think that's like, I think managing the trees and irrigating those trees the best that you can is kind of the priority when it comes to tree lawn. I think planting strips are really, really tough with things like that. And also just that amount of water, especially with standard NPRs in a space that tiny, that's just a lot of water for a turf piece that size. And I'll be the first to tell you that if we knew that we had a really awesome solution for planting strips everywhere in this state, we would be using it. But it's actually really kind of a difficult thing just because there's so much wear and tear that's associated with those planting strips. It's small. The tree is really valuable to that for pedestrian safety, neighborhood value, things like that. So I'm going to go ahead and say we're working on it. There's I'm not the town, but I think just everybody, like within the space, like if we thought of something that was super, super good in that scenario, we would be using it.
What free or low-cost irrigation modifications should people start with this season?
Smart controller. I'd say smart controller is the absolute first one that I would do, and then pressure regulated spray bodies, followed by nozzles. If I was gonna do, I would do them in that order. But I would say that the smart controller and that level of control is going to be the best, followed by just the point of emission stuff. Same thing with the audit. Like, I would say the audit too, like, get that done. Even if you don't have the capital to do a professional audit, just do the home audit with the handout that we gave you just to kind of see at least where your wet and dry spots are, and that's going to at least help you manage issues a little bit more efficiently.
Coincidentally, excellent next question. What features should you prioritize when upgrading the controller?
Just an ET-based controller is the one that I would really look at, and then also like using weather data in order to make the decisions. If you know you're not going to do any of the sensor ports or any of the smart sensors, I don't think that's super necessary, although most of them today do have that capability. But an ET-based self-adjustment controller that has sensor ports is going to be good. And I think the app control, that's almost a given now. You're not going to really have too many manual input smart controllers anymore. Those kind of have gone away with just irrigation technology in general.
With our hot, windy summer afternoons, when's the best time of day to water?
So that can be kind of a tough question, but I would tell you like between 3 and 4 a.m. is probably going to be the best time to do that. Some people actually like to get it even closer to the morning, closer to 5 if you're an early riser. If you need to look at your irrigation, it's easier that way. Some people also think that just watering a little closer to daybreak when ET rates are like kind of at their absolute lowest, that allows that water to be more effective longer, but you have to go longer between irrigation. It kind of depends on what you're watering from a scheduling perspective. But I would say anytime in that early window, try and get that thing, like wind is typically the lowest, like in the middle of the night, unless it's like the March we just had. Gosh, who lost a fence in here? Anybody? Me. But yeah, I would say like between like 2 and 5 are going to be your best times, even 2 and 6. One thing that's really interesting, actually, if everybody is watering at that time, this is why your pressure is really important. The whole general pressure, actually, of the overall system goes down because there's so much water leaving the system. So you want to make sure that you have some excess pressure available within your system, just so you're not getting a low pressure situation, because if you have every single person turn their irrigation system on right at 4, that can cause an issue.
I think we have time for one more. If somebody already has mixed plantings, different water requirements in a zone, what's the best thing that they can do to improve efficiency without redoing everything?
So with mixed planting requirements on things like that, I mean, the best thing to do if you have an automatic drip system is going to be just make sure that you are changing your emitters. So with drip emitters, you're going to have ones that are a half gallon per hour, 1 gallon per hour, 2 per hour. If you know that you have like a hydrangea next to a yucca, for example, a very extreme example of this, you're going to want to make sure that you have half as much water going onto that yucca than you do the hydrangea, and that's going to effectively have the precipitation rate within like that run window. It's kind of tough. You might need to rerun the poly, so you don't have to use like a million goof plugs to do that. But it's definitely an option without rerunning everything. But definitely you can manage it a little bit with emitter count. Generally speaking, I would still recommend like strong hydrozoning practices. But if you have established plants that you obviously don't want to rip out, manage with emitters is going to be my recommendation.